Hi ladies, this video is for lesson 8.1 and it's the worked out solution for number 15. We did not get a chance to go over it in class, we ran out of time, so I'll post this video instead. And for this problem, it looks a little complicated because it looks like you have several different triangles in here, but we're going to actually look and see what all of those dotted lines and those perpendicular segments are. So we could solve for the area. It's not asking us for the area, but we know that the area of a triangle is 1/2 base times height. So let's start there. But looking at this problem, we don't know the area of the triangle. And in this first, in the shaded region, the height, we can see that is x. So here's our base, 15. And here's our height, x. Now, we could solve for x if we knew the area of the triangle, but we don't. So let's just jot down what we know so far. And so if the base is 15, then the height is x, and the area is 1/2 15x. But we don't know the area, and we don't know x. So this formula, area equals 1/2 15x, doesn't really help us. We're going to leave it because we're going to show everything that we know, but with just this formula, we cannot solve for area or x. So let's look at something else we know. So let's think of this figure where the base is not AC, but the base of the triangle is a different side. So maybe now, instead of the base being AC, let's think about it as the base is BC. And if the base is BC, we need a perpendicular segment that gives us the height, which in this diagram is given perpendicular to BC is a segment that's 5 feet long. So now we can say that if the base is BC, which is y, then the height is 5, and so the area is 1/2 times 5 times y. Now again, with just this formula, we don't know the area, so we can't find y, and we don't know y, so we can't find the area. So let's look at it one more way. So since a triangle has 3 sides, it could potentially have 3 different bases. So let's look at the third possible base for this triangle. So we already used a base of AC, we already used a base of BC. So now let's look, if the base was AB, then the height is the perpendicular segment from AB to the opposite vertex. So now in this case, if the base is BC, which we know is 6, then the height is that perpendicular segment, which is 9. And so the area is 1/2 times base, which is 6, times height, which is 9. So now we don't know the area, we don't know the x, and we don't know the y, but now with this third formula, where the base is BC, or 6 feet, and the height is 9, we can find the area of that triangle. And since all of these give us the area of the triangle, we can set them all equal to each other. So by setting these all equal to each other, we can find the area, we can find y, and we can find x. So it'll just take a little bit of algebra, and so I'll show those steps and then post the solution. And what you should get for x is 3.6, and what you should get for y is 10.8, and so we'll show you how those values came out. So the area of our triangle, 1/2 6 times 9 is 27. That's equal to 2.5y, which is also equal to 7.5x. So when we solve for y, we get 27 divided by 2.5 is 10.8 feet, and 27 divided by 7.5 is 3.6 feet. So that's how you're solving for those two variables, x and y. You're thinking of three different possible bases.